All right, welcome. Another day, another coding challenge. This stream is for entertainment purposes only. With that being said, let's see if we can crack another problem, another random problem today under 40 minutes. Always forget to turn the sound off on the second device. So what we've got today, let's see. Pick one. It's a hard one. Damn. Not the best way to start weekends. All right. So number of ways to stay in the same place after some steps. You have a pointer at index 0 in an array of some size. At each step, you can move one position to the left, one position to the right, or stay in the same place. The pointer should not be placed outside the array at any time. Given two integers, number of steps, and the length of the array, return the number of ways such that your pointer still at index 0 after exactly steps. Since the answer may be too large, return it modular to 10 to the power of 9 plus 7. All right. So steps 3, array length 2. So we start at 0, so we can move 1 back, no. So we can go right, then left, and then stay, yes. You can stay, then right, then left, right, right, stay, left, and just stay, stay, stay. Interesting. So another example. Example 2. Steps 2, the length of the array is 4, the output is 2. So steps 2, length is 4. There are only two different ways, seriously? We have 2 steps, that's why. So the more steps, the more ways we can basically jump within the array, because we can stay, then jump, then stay, then jump, then stay, backwards, and so forth. But if we have just 2 steps, let's say stay, stay, and then left and right. Yes. Or right and left. Yes, correct. So there are only 2 ways. Now it's okay. It's basically, there is nothing really to code, I guess. It's just some math formula that you should retrieve out of this under these rules. Maybe, presumably. Maybe not. So the number of steps can be 500, which means all possible iterations, like go through all possible combinations here and check if it's feasible within array length is definitely not possible. It doesn't make a lot of sense. So I think that should be formula. All right. Let's switch to the whiteboard and see if we can do something here. So let's go to the example 3, which says length of array 2, but number of steps is 4, and doesn't give any explanation here. So we can try to see ourselves how it's done. So let's say we have array with 2 position, 0 and 1, right? So it's length 2. So we start here, right? And then we have how much? 4 steps. Steps 4. Obviously, the minimum answer, even if we have 0 steps, there is always, I guess, 1, right? So 1 is always the answer. So let's see, steps. So can steps be 0? Let me check. No, steps minimum 1. Okay, so we start with 1. So we don't need to worry about special case. 1, 2, and 2, 4. Let's check case steps 1. So we have 1 step, right? When steps 1, obviously the only way is just stay, right? We can't do anything else, no matter the length. So step 1 is an easy one. You just always return 1. If we have 2 steps now, steps 2, we always have 2 unless the length is 1, right? So if length, so steps 2, we can either stay, or right, left. Right? So this is 1 always. This can be either 1 or 2. So 1 if length is less than the number of steps. Oh, actually, just 1. If length is less than 2. So then we basically just stack it 1 pointer. So those are special cases, I would imagine. So number of steps 1 or array length equal 1. Then no matter how many steps you have, you cannot move anywhere. You just return it, right? If you have at least array length of 2, then you basically unbounded. You can jump back and forth, like right, left, right, left, right, left, right, left, until you stop. Although if you have more than that, then you're allowed to have left, 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 and then right, 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 right. So these combinations won't be allowed if the array length is lower. Okay, so let's see, steps 3 in this case. Right, so for 3 steps, it's basically the first case. We should have 4. Right, left, stay. So right, left, and then stay. Something like this, right? All stay. So stay times 3, right, left, and stay. Whatever possible combinations we might have in this set. So how many ways? If we have 3, in this case, 3 operations, we may combine them the way we want, right? So you have 3 steps. So it's right, left, stay, right, stay, left, and left, stay, right, I guess. No, we can't. No. It's wrong. So we have right, left, stay, right, stay, left, stay, right, left. We're not allowed to have first left, then right, because in this case, our pointer will go to the side. Yeah, our pointer won't be sufficient. Okay. Yeah, I don't see any significant key here that suggests us to simplify this. I mean, obviously, okay, in steps 4, let's see, steps 4. Let's just write them down when we have steps 4, right? So it's stay. Okay, you won't be able to see it. Stay and basically another 2 times like this. Then we can stay 2 times. Then right, left. Then we can write stay 2 times and left, right, and then we can right left, stay 2 times, right left, stay 2 times. All right, so we're about 8 minutes into this problem. So this is 4, but we should have 8. So then we might have, let's say, right, left, right without stay, right, left, right, left, and that's it. I don't see how come it's 8, to be honest, because this is stay, doesn't matter, right? It's just always stay, right, left, right, stay, left, right, left, stay, right, left, right, left. Maybe we can stay once. Let me check. If we go, let's say right. I see. Yes. So this group, right? We have, where is this? This one, 3, right? But technically we can also stay, then right, then stay, then left, right? So all possible combinations, we stay right and left here. So not all possible combinations, whatever. So there is always one special case is this. There is, I guess, could be a special case when no stay operations involved, when you just right, left. There can be special cases when we just right, left, and we stays. Still don't understand the formula here. I would say, let's see. Let's switch to the code itself. So we already see 2 things. If array length equals to 1 or steps equals to 1, right? So it's basically a special case. We return 1. Very simple. However, yeah, let's do it a little bit more. However, if it's not the case, so if array length, let's say 2, if array length is greater than 1 and steps are greater than 1, then we might have something, right? All right. I think the key secret here is basically compute all possible combinations just based on the number of steps, how many total number of steps we can do, because we have only 3 combinations, right? And once, yeah, and once this is done, so first, compute total number of steps combination. Then, second, then subtract number of unfeasible combinations based on array length. So the second one is more trickier. All right. So we know the set and we know the number of unique elements in it, right? So let me see what's the formula for this. I don't remember it. Number of combinations of n elements in whatever of n elements. Number of time is. Let's see. Mathematics. Yeah, these things. Do you remember these things? So here's the example. Number of combinations of 30 players taken 4 at a time. The number of combinations of distinct objects taken R at this time. Okay. So we have total number of steps, right? Which is basically n. And let me copy this. Keep concurring with code with Control C, Control V, where n is basically number of steps, like, right, steps. Not sure if factorial is in standard library, whatever. And then we have basically 3, which can be computed once, right? Factorial 3, let's say we just computed it once, which is straightforward. Which is 1, 2, 3, which is 6, right? Just to know that this is factorial 3. And then we have steps minus 6. Here we go. So if steps is less than 6, then this thing will be negative, and it shouldn't be, right? Interesting. It's not quite. Yeah, I don't think it's quite correct to do this formula here. So a few reasons for that. So how many steps? No, we pick steps, right? So it's reverse, I guess, from the collection of 3. So if it's, but it still can be negative. Okay, let me see. So let's assume this example when we have 4 steps. Steps equals 4, right? Length 2. Steps 4. Okay, let's just do steps 3, right? We have 3 of them. Obviously, right, 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 left, left, left. Or should we do this? Should we compute it in a cycle, maybe? So the array length is from 1 to 10 to the power of 6. So we theoretically can do linear complexity here, I would imagine. So if we go just through the array and try to do and count steps. But this is total number of steps. Right, we're already almost 20 minutes into this problem and we still have, basically we have 0, except in this case. Nice, like these kind of problems. Okay. So something I missed something here. Int result starts with 1, I guess, obviously, because we can always stay no matter what. And then return result. Okay, so while number of steps is greater than 0, we can do left, right, right, left. And then we should make sure that we always stay within array, right? So let's imagine we have 3 steps, or let's say, yeah, 10 steps, and in array 10 it will be too much. And there should be, no, I still think there is a formula. Many people like this problem, by the way. So it seems like once you know the formula, of course, it will be obvious to solve it. There are 2 different ways to state index 0 after 2 steps. Right, left, stay, stay. So every time, okay, so let's look from different angle. Let's imagine we have, like in this case, right? Steps 4, or maybe even steps 6, and length of 3. So then we can do right, 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 and left, left, left. Aside from all other combinations, right? All of the previous combinations. So the only difference between this and this, right? That when we move here, we might be able to allow one extra operation, but okay, this will be too much to see. But okay, let's try with steps 2 first and length 2, and then move to steps 3, right? So in steps 2 and length 2, we basically allowed stay, stay, right, left. So 2 combinations. So we say stay, stay, and right, left. Now, if we increment steps, let's say stays 2, but length is 3, it doesn't change anything because we should return back to 0, right? So if length is greater than the number of steps, it doesn't impact number of combinations, right? We might have. That's the interesting thing. But if it's less, then it does. All right. So seems reasonable. Okay. Let's imagine that we stay 2, but now increasing by 3. So another finding here, put it if length is greater than steps, number of operations, I think even steps by half or something like this, right? So it's the only, if it's shorter, then it impacts. If it's greater than that, it doesn't really impact because we can travel wherever we want. Operations is not limited. Number of combinations, not operations, is not limited by array length. So then we really consider steps and the length of the array. So in this case, we already know the answer here, right? It's this one. So let's carefully go through this and see for some key to the solution, right? We're roughly 25 minutes into the problem, so 15 minutes left. We basically still have nothing. Okay. All right. So okay, we have 3 operations, right? And if we imagine that we allow to combine them in any possible way, right? It's in any possible way. Then we don't just have 3 operations. We also have number of steps. So how many times they can repeat each other. Number, let's see if Google knows something. Number of ways to place n elements in K-set or something. Or K-subset, is it this one? Given 2 numbers and K presents a number of elements in a set, find a number of ways to partition the set into K subsets. Let the set be 1, 2, 3. We can partition it into 2 subsets in following ways. 1, 2, 3, 1, 2, 3, 1, 2, and 3 and 2. Yeah, something similar, right? Because we have just 3 combinations, so we can combine them these ways. So our n is always 3, and the way we partition it is up to 4. So is there any formula for this? There is a recursive solution for it. Okay, I see. That's what they want, I guess. That will also exclude some corner cases. Turn 1, count P plus K, count P and plus KK. I see now. So there should be somewhat internal function, right? That does int numbers internal maybe the same thing. Or maybe we don't need internal. Maybe we can just call this thing just reducing number of steps by one, because we know the step 1, step 2, how it should be, and then we can call it recursively to sum until all things done, right? Or maybe no. Yeah, I think just return something like numWays one scenario plus numWays another scenario. Maybe more. Okay. Let's see if we can do this. Steps are length, steps are length. 10 more minutes left. So I have no idea what to do. Happens, but I guess we should try to do something. Okay, so if steps 2 length 1, right, left, right. Yeah, I don't see it's it might be, by the way, just something simple like 1 plus something and some special cases, or it might be a recursive version. Maybe let's say subtract number of steps, because let's say if we just stay, it's the same as just step equal 1, right? If we write left, but number of steps is 2, else if steps equals 2, and we definitely know that array length is greater than 1, right? We also know the result. It's kind of known for us. We can return 2 because we do stay and right left, but oh, I see. And we can also subtract array length, right? So if array length, when array length is 2, we still can have many ways to do it, I guess. Stay, right, left, and then combinations of stay and right, left, so it doesn't really affect significantly us. So let's return back to this problem and see K, S, and Y, so how it works. So what is K? K is number of subsets in the sets, right? In n elements. So we reduce it by 1 times K times this plus this. Interesting formula. So how did they came up with this? Just curious. Did they do this one by one to come up with recursive formula? Yes, because this, I don't think it directly fits here. So we can just multiply to k number of subsets. Like how many ways, right? It's basically what we need to find, I guess. Mm-hmm. Okay. Or no. So k is how many number of subsets we might have. That's what we need to compute. Count number of ways. Number of ways we can split it to subsets. Right, so combination of, so we have 3 elements. The number of subsets is, I guess, number of steps. So is it always 3 then? And steps times this? And, yeah, I don't understand. So how to get to 4? Just stay, right? Steps 2, return 2. How to compute this thing? I don't understand. So right, left, stay, stay, right, stay, left. Don't see any clue. So we have approximately 5 minutes left. Yeah, I don't see anything. I don't see good ending today for this coding challenge. Seems like it's a failure, but that's fine. That happens. I would imagine if I will look into the solutions for that one, there will be some either recursive formula or something like that. Or if you spend just more time on it, you will eventually figure it out dependency. But this is a little bit tricky. So, so returning back here, right? Stay 3 times. So number of ways we can always just stay. It's always the case. So it's always 1 plus something. Plus right, left, stay. Is it? Yes. So this one. So we know that we can move pointer until arrLen. Then maybe compute it recursively somehow, or I don't know. Yeah, definitely. We can go if array length is not 1, but number of steps is 2. So what if if array length is yeah, we can do whatever we want. We can jump back and forth if at least it's 2. So array length doesn't give us much. So number of steps. Okay, so let's just solve for this special case in example 1 to pass maybe at least something. We still have like 4 minutes. So while steps are what? Steps greater than 0, right? Int cnt equals 0 or equal 1. We know the one case, always the case. So we can go. No, it doesn't work that way. It seems like it's just the mass formula that you need to figure it out. And maybe it can be computed recursively. So it should be like sequence of these things. So right, left, stay, right, left, stay, left, stay. How do I come up with this? So So array length is obviously plays a role how many right and lefts I can take, right? So, and I can take as many stays as I want and place them in any place I want. So we always know, okay, so it's another hint. So we always know that number of rights and number of lefts is equal, right? I think int max left, right, is equal to about half of it. And int max right is equal to max left. Max left. So they can both be 0. In this case, it's only stay. They can be 1. In this case, stay can be either before or after them. If they're 2, then there are more ways we can place stay. They can be like in sequential. But even this formula, I still don't understand how to do it. It's 1, 1. All right. So while max left, let's say, or max right is greater than 0, then we do what? CNT plus equal. So we start with max right and max left, right? So we go one way and another way. So in this case, damn. Yeah, it's not that easy anyway. All right. Okay, the time expired. So this is total complete failure now. I even didn't switch the scene. Yeah, that's fine. So, all right. So we can return anything here, right? So let's return very dumb thing. let's just return what it's supposed to be for, right? Because we already know it's for. Okay, so it doesn't work, but if you just run the code, of course it will compile. And maybe we will pass one test out of 1,000. Submit details. So we passed 5 out of 31. Okay, yeah, let's just see what's, I think it's, okay, it's dynamic programming. See how it's done, how smart people do this. So because steps less than 500 and the max index used is 251. Oh yeah, yeah. It's how far you can go, I guess. Steps 500. Yeah, we don't care if it's more than that. That's true. Then we say, okay, int ve and n. So if steps equal 1, return 1. Obviously, this is 1. So we had this special case. So we've got some 5 out of 31 test passed. Oh my gosh. V0, V1 is 1. arrLen minus 4. Okay, let's see. So we don't need any increment. So if steps greater than 1, and we subtract steps and do this. This is our modular, right? V and modular. Ooh. So how did they come up with this? So why the sum of the previous step? Like I guess, if we switch back to the whiteboard, so we consider swap NV. Yeah, I need some explanation for that. I don't understand. Um, yes, let's say beginner's approach. Somebody used DFS, interesting. Avoid unnecessary computation steps and minimum. This is our N. Current new intent plus 2, previous 4 steps. So we start by step, and then there is a row. Current. Nope. Still don't understand. Optimize it further, take into arrays instead of matrix. The time I got, then I realized that I'm doing unnecessary computation, so reduce the array size to number of steps. Yeah. Yeah, if it's a dynamic programming, it's obviously. So in dynamic programming, the problem is either you get the key fast and then you figure it out how to solve it. Yeah, it felt like it's dynamic programming. It's still not clear to me even at this point, even seeing some solutions. You go in some crazy numbers multiplying something. Curious though how long it took for people to quickly get the problem. Or something easy, dynamic programming. Let's see. Oh, yeah, let me switch back to the default scene. So we start, yeah, we got it. So number of steps by 2 plus 1. The, like how far we can go, right? Obviously, it's either number of steps by half plus 2 or the length of the array, whatever is less. The rise of positions. And then, so basically for every number of ways how far we go, we compute all possible combinations, right? And then we sum up this, I guess. And then we, of course, divide this by modulo because the result can be super large. But, okay, so this is the main thing. So the current position where we are, so how many combinations we can take to get to this position, right? And while steps greater than 0, okay, feathers position plus 1, obviously long. And we say, okay, so from 0 position to the furthest possible position where we never can get. We say it's a previous position, previous I plus 1 plus previous I plus I greater or equal 1, previous I minus 1, or 0. If I greater or equal to 1, oh, okay, it's just the coordinate case. Assuming that I is greater, so it's like 2 or something. Then we say previous is equal to current. And current is what? It's the same size as previous. So we save it to the previous and calculate it again, right? By subtracting step by 1 now. Ooh. Interesting. Yeah, it's not clear how they came up with this. But I would imagine if you do more examples and do the math, you will figure out that splitting problem like this will work. Okay. Yeah. Yeah, dynamic programming is always bad. It's really not always. Actually, we encourage to not ask during the interview dynamic programming based problems because during 40 minutes, it just might not be enough time. Somebody can get it quickly or somebody solved something similar with the dynamic programming and they say, yeah, I know this. Others, no, they will just stuck and that's it. All right, so the idea was basically, let me switch to the whiteboard. So the idea was to go no matter length of the array, right? Figure out the maximum furthest position from zero index you can go, let's say k, right? And then at every step, for every position is basically, so we start with previous equal 1 and 0 everywhere, right? So then our next one will be what? This one, 0 and 0, so it will be 1, right? So do we ever go to the second one, I wonder? So if I is equal to, let's say, so it's 3, or let's say I is equal 1, so this one, right? We say this one is this one plus this one, which is still 1. Okay. No. Or, yes. And the previous I minus 1 is 0. So yes, so it will be like 1, 1. So this is this is step 1. So step 2, this will be what? This is 1, right? Because now we use the result on step 1. This is still 1. For these, no, this will be 2 already because we also use this one. For this is also 2. And so for this one here, what it would be, current, previous, just I guess 1, because we, no, previous here is 0. So we use these 3 to calculate this, third index. So it's 0. Now we use these 3 is 2, this 3 is 2, and here is this 3, which is 1. All right, so for step 3, it's, yeah, good luck to come up with something like this. It's even now it's still kind of painful to understand the logic behind it and how it relates to left, right, but I got it. So right, left, and then all possible combinations in between, you compute them this way. So this gives you what, 4, this is 5, and this is 3, right? So this element was nothing here. Now this element is something like 1, right? And then we keep iterating. So for step 3, for 3 steps, right, the result was 4. And that's what is here. So we return the 0 element. Interesting. And obviously we track the remainder of modular. So we need to also divide this by 10 to whatever 9 plus 7, like percentage wise, because those are positive, so it's modular. Okay, yeah, not easy to come up with something like this. So yeah, I see it, but yeah, to quickly understand that this is something. Initially, I thought it's just the formula that you can apply and modify a little bit. Can we? Okay, let's see to the default scene. Wonder if we can add some likes here. No? Okay. Yep. So that's why it was hard, because it's dynamic programming. So we return to the submissions. Obviously, it's incorrect, but we have just 5 out of 31. Which basically, we got some corner cases. We tried to crack it. We were unsuccessful. So failure as usual. So returning back to whiteboard. Yeah. So everything is 0 here. 0, 0. And this one is what? 5 over 31. So in this case, we would just like, oops. No. Nope. Let's retry. Kinda trying to not be too embarrassed here. All right. So where is our wasted GTA sound effect? All right.